Hi guys, and welcome to another video. In today's video lesson, we continue on the series of grade 11 trigonometry, and the video that we're looking at today is going to be grade 11 maths trigonometry and solving trigonometric equations. We're going to be looking at the general solution and the specific solution in an example. The question that we're going to be looking at today is from the November 2018 paper 2. Let's quickly have a look at the work schedule. Now, this is a work schedule for 2020. It seldom varies or changes over the years. It's basically the same thing. So we're looking at trig equations and the general solution. It says determine the general solution and or the specific solution for a given interval of trigonometric equations. And if you looked at the website, you'll be able to see that trigonometric identities and reduction formula, all the videos have been completed for those particular sections. So be sure to have a look at jlmaths.com where you can watch all videos in order of the work schedule. So let's get straight into it then. From the November 2018 paper 2, we are looking at question 5.4 here, where it says determine the general solution of 3 sin x equals to 2 tan x. If you've watched the videos or if you went over identities in school, you'll know that whenever you see tan x, you need to change it to sin x or cos x, because tan x is equal to sin x or cos x. So when we're solving equations, similarly, we need to do the same thing. So it's going to be 3 sin x equals to 2 times tan x. We're going to change it to sin x over cos of x. So 3 sin x equals to 2 into sin x over cos of x. Now let's open these brackets out here. So we're going to be left with 3 sin x equals to 2 sin x over cos x. And as you can see here now, if we just cross multiply, or you can just multiply by cos of x, it's the same thing. You can multiply by the LCD cos of x or just cross multiply. You'll get 3 sin x times cos x equals to 2 sin x. So now we want to make one side of our equation equal to 0 so that we can solve. So therefore we're going to get 3 sin x cos x minus 2 sin x equals to 0. As you can see here now, we've got sin x, which you can now remove as a common factor. So therefore, you're going to say sin x into 3 cos x minus 2 equals to 0. So now you can see that we took out sin x as a common factor. So therefore, what are we going to be left with? Well, we can be left with sin x equals to 0 or 3 cos x minus 2 equals to 0. Let us solve over here now. So we're going to be left with 3 cos x equals to 2. Therefore, cos x equals to 2 over 3. Now, if you've watched the previous video, remember now at this particular stage, after solving the equation, now we need to get our reference angle. So our first reference angle will be reference angle here, sine inverse of 0. You can use our calculator for that. You should get 0. Right? Because remember that for your sin x graph, when y is equal to 0, x is also equal to 0. Alright, so if you know your basic graphs, you tend to understand this a little bit better. So let's look at that. So we're going to say shift sine 0 and we should get 0, right? So that will be 0 degrees. So what does that mean? It means that when y is equal to 0, for y equals to sin x, x is also equal to 0 degrees. Here, when y is equal to 2 over 3, what we're going to get for our reference angle here equals 2. So it's going to be cos inverse of 2 over 3. Cos inverse of 2 over 3. We use our calculator once again. So we're going to say shift cos and 2 over 3. A question that students often ask me is, if this is negative, like you got cos x equals to minus 2 over 3, what must you do to find the reference angle? Well, you must always find the positive of whatever value you have here. So even if you had cos x equals to minus 2 over 3, you will find the reference angle of cos inverse of 2 over 3, right? And I'll explain further what needs to be done. So here we are left with 48.189. So we'll round up to 2 decimal places. So this will be 48.19 degrees. 48.19 degrees is my reference angle there. So at this particular stage, learners, it's important for you now to know your cast diagram. Cast diagram is important because we need to see now where sine is positive in this case and where cos is positive in this case on our cast diagram. Now remember now that that's your first quadrant, second quadrant, third quadrant, and fourth quadrant. Remember that all ratios are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. Formulas, reduction formulas are as follows. That's theta 180 degrees minus theta there, and 180 plus theta, and here we got 360 degrees minus theta. So those are our reduction formulas, which are very important because that's what we're going to be using now to write our general solution. So let's continue. Now at this particular stage now you need to look at, okay, see a sine x equals to 0, right? So 0, remember, is taken to be positive. So therefore now at this particular stage you need to say, okay, where is sine positive? Sine is positive in the first quadrant and the second quadrant. So accordingly you need to use those particular formulas. So therefore we are going to now say for the first quadrant, theta now is our reference angle. So we're going to say x equals to theta, which is now 0 degrees. There's your reference angle here, right? So you're going to say 0 degrees plus k dot 360, and KEZ means k can be any integer value. I didn't have to say 0 degrees plus k dot 360. You could have just said k dot 360 KEZ. Nevertheless, 0 degrees plus k dot 360 is perfectly fine for you to write it like that. Leave it like that. Or for the second quadrant, remember, for the second quadrant, your reference angle here is what? 0 degrees. So we'll put that in the place of theta. So 180 minus 0 is 180 degrees. So now we'll just say x equals to 180 degrees plus k dot 360 KEZ. And that should do now for our first part of our solution. Now let's look at the second part of our solution. So for the second part of our solution, here we got here that cos x equals to 2 over 3. So once again, guys, this is positive. We need to see where cos is positive. Remember, cos is positive in the first quadrant and it's positive in the fourth quadrant. So similarly, we're going to write our answer for the first and fourth quadrant. So therefore, for the first quadrant, remember the formula is theta. So we'll say x equals to 48.19 degrees plus k dot 360 degrees. K can be any integer value. And for the fourth quadrant, we're going to say x equals to, remember, the formula is 360 minus theta. Theta is your reference angle. So you'll say now 360 minus 48.19, 48.19, and that's equal to 311.81. That'll be 311.81 degrees plus k dot 360 KEZ. I've already explained in the previous video why we write k dot 360 for sine and for cos functions. Okay, remember, because the period of y equals to sine x and y equals to cos x, 360 degrees, which means the graph repeats itself every 360 degrees. Now that is the general solution. So for this particular question, we'll actually stop there. We don't have to go further than that. Now, because I'm covering both general solutions and specific solutions in the same video, let's say, for example, they gave you a domain. So for a specific solution, they will give you a domain. Now, once again, I must tell you that for general solution, you would stop at this particular point. The specific solution, you'll just take it one step further. Let's say they gave you the domain x. Here in the domain from 0 to 360 degrees. That means they only want answers which lie in this particular domain from 0 to 360 degrees. And normally that will probably get tested now under trig graphs, okay, where they'll draw the graph and they'll ask you to find the intersection points and so on. So therefore, remember that the process is basically the same. What you need to do now is basically just program this thing in the calculator. So we can program the first one there now. And so let's always start. I will start here 0 plus k dot 360. So once again, you will say 0 plus. Now for k, you just put open and close brackets and then times 360. So in the brackets here, you can put any integer values here. Right? So I chose a fairly simple example or domain for us to actually work with. But the process is the same throughout. 0 plus k dot 360. See, if you put a minus 1 there, you get minus 360. Now, minus 360, as you can clearly see, does not lie in this particular domain, right? If you put 0 there, you'll get 0. If you put 1, you'll get 360. So there's actually two solutions here, 0 and 360. So you'll say x element, open curly bracket there, 0 degrees and 360 degrees we'll get there. Okay, so the first one is done. Let's look at the second one. See, for the second one, you got 180 plus k dot 360. So you put 180 plus, for k, you put open and close brackets times 360. Once again, learners here, if you put minus 1 there, minus 1, you'll get minus 360 plus 180. You get a negative answer there, minus 180. Now, we don't want that. Well, that doesn't fall in that domain. So that's that we don't need, we can't accept that rather. So here, if you put 0 now, we'll get 180, which lies in the domain. So 180 degrees. And if you put 1 there now, you're going to get a value greater than 360. All right. So now let's move on to this now. The next one here, which is, as you can see, we are moving on 48.19. So it'll be 48.19 plus k dot 360. Remember now for k, put that times 360. So if you put a minus 1 there, you're going to get a negative answer. If you put 0, you'll get 48.19. If you put 1, you're going to get a value greater than 360. So the only answer that's acceptable within the domain is 48.19. So we'll write down here 48.19 degrees. And now let's go look at that one. 311.8181 plus open and close brackets times 360 degrees. So here, once again, if you put a minus value, you're going to get a negative 1 there, you'll get a negative answer. And we only got positive values here from 0 to 360. So you're not going to put that 0. Your answer will be acceptable 311.8. So that will be 311.81 degrees. And if you put 1, you're going to get quite a large value greater than 360. So we can't accept that. That's not in our domain. So these are solutions in the domain from 0 to 360 if this was a specific solution. Notice if you haven't subscribed already, subscribe to my YouTube channel, JL Maths. Also, you can watch all videos in order of the work schedule on jlmaths.com, like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.